Assalamu alaikum wa rahmatullahi wa barakatuh. I'm gonna go get this over and done with because I have a lot of work to do and I don't have a lot of time until Isha. It's like less than half an hour, I think. I shall probably check when Isha time is. Okay, I'll just leave at 50 past 5, which is in 25 minutes. Okay, so I'm gonna get my integration homework done, which I was literally supposed to give in today, and then I'm gonna mark that, and then and then I also want to get some physics work done, so let's do that real quick. Cool, okay. Nice. So there's actually two parts to this integration year 2 work. There was homework part 1 and then there's homework part 2. Homework part 2 is to do with trapezium rule and differential equations. So for example, this is a differential equation, and then we have to solve it by finding out what the constant is, and that's literally just, or actually, solving a differential equation just means you get the variable not as the derivative, so integrating. Yeah, alright, let's get started. I've done 3 of the questions, and I'm on the 3rd one right now, and then I have 2 more. Okay, so I just split this into partial fractions. Now I need to find the exact value of the derivative of the integral of the partial fractions. So I'm integrating the partial fraction. I should probably show you the question too. This is el question that I'm doing. Equals when you're integrating. Nice. Where's the calculator? So when you're integrating a partial fraction and it's bottom heavy, then you just do ln of the denominator. So for example, this fraction that I have now is 5 over 1 minus 4x. So the integral of that fraction on its own would be ln 1 minus 4x. And then if you integrate that, you'd get 1 over 1 minus 4x multiplied by minus 4. So you'd have a numerator of minus 4, but we want a numerator of 5. So you need to do what multiplies by minus 4 to get to 5. So you do 5 divided by minus 4, which is minus 5 over 4. So it's like the integral of that fraction is minus 5 over 4 ln 1 minus 4x. I mean, it would be useful if I had a whiteboard right now, but you just have to understand my speech, and hopefully you do. So yeah, minus 5 over 4. And then same with 6 over 2x plus 3. So if we do ln 2x plus 3, we'll get 2 over 2x plus 3. But we want 6, so we just multiply everything by 3. And then 0 minus 1. Okay, now we just need to solve that. Ln of 1, do you know what it is? Ln of 1 is just 0, because if you look at a log graph, it has a y-intercept of 1. So when the function of the logarithm is 1, that's when you know the x value or the x coordinate at that y-intercept is 0. Did I explain that well? I don't know if I did. I'm so confused. No. All you have to know is ln 1 is 0. Let me see if log anything else is 0. Log 10 base. Oh, wait a second. Log base anything, and then you put 1 inside is 0. That's interesting, man. But I do not have enough time to think about that right now. Okay, plus 3 and then 1 plus 4 is 5. 3 minus 2 is 1. Okay. So that gives us 3 ln 3 plus 5 over 4 ln 5. And then it wants us to give it as an exact value. Can we simplify that? I'm not sure if we can, to be honest. 5 5 to the power of 5 over 4. That's not a nice number. I'll just leave it as that. Does it want me to leave it as that? I don't really know. Anyways, 4a. The value of a computer v degrees. This is the question. There you go. Given that the initial value of the computer is v0, the rate of decrease, so dv over dt is proportional to the remaining value, which is v. Is it v? I hope so. You know, I haven't actually done any questions from this exercise, so I might be kind of cooked. Oh, but I guess that's the point of these videos anyway. dv over dt. The rate of decrease is proportional. So dv over dt is proportional to v. Or should it be minus dv over dt? Oh, I don't know. We'll find out anyway. I'm going to do minus dv over dt. So minus dv, since the is proportional, you can do equals kv, and then you put the v's on one side, minus 1 over v dv equals k dt, then integrate both sides to get minus ln v equals kt. Okay, yeah, that's the answer. Okay, I hope so anyway. Oh well. Remove the logarithm by doing v equals e to the power of minus kt. But why v equals v0? Why is that? Given that the initial value of the computer is v0, so when t is 0, e to the power of 0 is 1. So we want okay. I'm not sure if my working is correct. Oh well. Okay, 4b. Find the exact value of k. After 10 years, the value of the computer is 1 over 5 v0, which is the initial value, right? Oh no, it's after 10 years, the value of the computer is a fifth of its original value. And we have an equation for v. So 4b. So we have the equation as v equals v initial times e to the power of minus kt. After 10 years, so when t equals 10, and then v equals 1 over 5 v0. So 1 over 5 v0 equals v0 times e to the power of minus 10k. You can cancel by v and multiply by 5, which gives 1 equals, or no, you can just do 1 over 5 equals e to the power of minus 10k. Take ln of 1 over 5 equals minus 10k. ln of 1 over 5 is the same as 5 to the power of minus 1, so ln 5 equals 10k, k equals ln 5 over 10. Okay, 4c. How old is the computer when its value is only 5% of its original value? How old is the computer when its value is only... Okay, so the value, v equals 5 over 100, which is the same as 1 over 20 v0, which is the initial. So we want to know how old it is. So we just substitute in the original equation. So 1 over 20 v0 equals v0 times e to the power of minus ln 5 over 10t. Okay, so let's just cancel 1 over 20 equals e to the power of minus ln 5 over 10t. You know, in this scenario, I'm not sure exactly what to do. But let's see. I'm gonna do some experimenting. So e to the power of minus, or just e to the power of, yeah, let's do minus ln 5 all over 10. What does that do? That gives me a weird number. So you can't just like take that apart. I could ln both sides. So ln minus ln 20 equals minus ln 5 over 10t. And then divide, so 10 ln 20, just rearranging, equals ln 5t. So 10 ln 20 all over ln 5 equals t. I hope that's a positive number. If not, that means you can't have negative time. So that is 18.6 years to 3 significant figures. Yes. So how do we check that's a suitable value? So we know that after 10 years, it's 20% of its original value. So we can expect that after 18 years, it will be 5% of its original value. So this value is plausible. It doesn't mean it's correct, but it's at least not impossibly wrong. Okay, next question, or the last question. A large cylindrical tank has radius 40 meters. Water flows into the cylinder from a pipe at a rate of, okay, so dV in, because it's rate of flow, over dt equals 4,000 pi, while dV out, the rate of water flowing out of the tank, is 50 pi h. So that means dV over dt is just dV in over dt, take away dV out over dt, which is the same as 4,000 pi, take away 50 pi h. Okay, so we have an equation for dV by dt, but we want dH over dt, and dH over dt can be retrieved by doing dH over dV multiplied by dV over dt, which we got before. So how do we get dH over dV? So we know the radius is 40 meters. So let's get an equation for volume, because maybe it'll be helpful. So volume of a cylinder is pi r squared h. So 40 squared should be 1600, right? Yeah, 1600 pi h. How does that help? So we want dH over dV. The depth of the water. We have V. Do we differentiate that? Wait, so we want dH over dV. Yeah, we just differentiate that. What am I doing, man? What am I doing? Okay, whatever. So we have V equals 1600 pi h. So dV over dH, which is the opposite of what we want. We can just inverse it later. Dude, I don't even know if that'll get you the answer. We'll try anyway. Equals 1600 pi h. So it just gives us 1600 pi. So dH over dV equals 1 over 1600 pi. That does not sound right by any stretch of the imagination. Oh wait, it is right, I think. Anyways, let's try it. So multiply those together to get dH over dt equals 1 over 1600 pi multiplied by 4000 pi minus 50 pi h equals 4000 divided by 1600. It's 5 over 2. What am I doing? Rearrange it. Just rearrange it, bro. Look, this is the equation I have, okay? Probably can't see that anyway. And it's literally very, very close to this. So instead of just taking the long way, just rearrange it to make it look like that. So 160 dH over dt equals, divide by 10, 400 minus 5h. And that's 6-mark question. Let's go. When t equals 0 and h equals 50, find the exact. Okay. When t equals 0, h equals 50. When t equals 0, do we have an equation with t and h? T and h. Oh, we probably have to integrate, man. That's probably what we have to do. So fun. Oh yeah, I remember. I saw my friends working. So much integration, so much ln, natural log stuff. What time is it? What time is it? I have 9 minutes. I can probably just do this question and then I have to go pay Isha. When t equals 0, h equals 50. So we have 160 . over 400 minus 5h dh equals dt on its own. Okay. We'll integrate both sides. So remember, we have the denominator as 400 minus 5h, so we do ln 400 minus 5h, and then we want the numerator as 160, so our current numerator is minus 5, so minus 5 multiplied by what gets to 160? Minus 32. So the integral is minus 32 ln 400 minus 5h equals, since we're integrating 1 with respect to t, we're just gonna put t there. Yeah. So we have what's going on, bro? We need a constant, otherwise this is pointless. When you integrate, you get a constant. When you integrate, you get a constant, man. So what am I doing? Okay. Okay. ln 400 minus 5h equals minus t plus c all over 32. So e to the power of 400. We're just going to remove the ln from both sides. E to the power of minus t plus c all over 32. Now that's a weird number. So when h is 50, so you can 400 minus 5 times 50 is 150. 150 equals e to the power of minus t plus c over 32. Now how do we separate that? We can do 400 minus 5h equals e to the power of minus t over 32, and then the rest is just a constant, innit? Times e to the power of minus c. Yeah, it should be a constant. Times k. Times e to the k. Times k. Okay. So when t equals 0 and h equals 50, e to the power of 0 is 1, so 150 divided by 1 is k, that gives us k is 150. Yeah. So that means when when h equals 60, 400 minus 300 is 100 divided by 150 is 2 over 3. So 2 over 3 equals e to the power of minus t over 32. ln both sides, t equals, that's weird, minus 32 times ln 2 over 3, and it wants the exact value. Let me check that. So if it's not a positive number, I'm gonna... Okay, it's a positive number. So we have t equals 12.97. Okay, now to... What time is it right now? 46. I can check some answers. Okay, homework, year 2, pure maths. I really want to check the answer, so I'm going to check it first. Okay, integration. Homework test. By the way, this was due today. I'm not sure if I told you guys that. Have I marked any of it? Yeah, I have. I'm gonna quickly search University of Nottingham ISOC playtime. Because I don't think they've actually... if it's not on the Instagram, then they just haven't posted it at all. Bro, I want to see the play times, man. Okay, they put the play times. It is... Okay. Today, I can't even see what date today is. Today's 4th. 57. Okay, so I have like 5 minutes. Okay. 2A, that's correct. That's 1 mark, right? 2B, yeah. This is trapezium wall. 1.61, yeah. Okay. By using an appropriate substitution, M1. Did I get the correct integral? Yeah. Yes, I did. Nice, sick. That's awesome. And I got the right answer. Okay. I did have a look at my friend's homework though, so can't give me all the credit for that. Okay, that's question 2. M1. M1 is just method marks, by the way. So even if you get the wrong answer, you still get the method marks right. If you use the correct method, of course. A1 is 5. Okay, that was 5 marks. M1 FT. Now I was at school today, and I was talking about, it was already like 4 or 5 p.m. and I was like, oh, they asked me, are you going home? And I was like, no, I have to film a getting cooked video. And I actually knew what I was on about. Like, why did this classmate of mine just happen to see my getting cooked video? I can't believe it. Can't believe it, to be honest. Okay, makes an attempt to integrate. Dude, that's completely wrong. Wait. It's not wrong. They just wrote it weird, man. Okay. dv over dt equals minus kv, yeah. Yeah. Yes. I forgot integration constant, man. I forgot integration constant. I don't have my watch, bro. What time is it? It's 5:50. Okay. I'm gonna have to rush out after this. Okay. Okay, I understand why I got that wrong. 4B. M1. Nah, man. Oh yeah, that's correct. They write it weird. They write it really weird. Anyways, they wrote ln 1 over 5 instead of doing minus ln 5. Who does that? I don't know. I do not know. Examiners do that. I'm not sure why. Did I get that right? Yes, I did. So it was 18.6 years. Okay, last question, M1. M1 for getting volume. Getting derivative, yes, nice. We have to reciprocal that. Okay, getting dv over. Attempt to find dh over dt. Yes, yes, nice. Very, very last question. M1, integrate both sides. Ooh. I mean, I got the right answer, so I'm gonna assume all my working was correct, because of course people have different methods. So that's weird, man. They're not gonna have the exact same. Okay, 1, 2, 3, 4, 5, 6. Okay, how many marks did I? Wait, 7, 1, 3, 6, 1. 5, 5, 4, 3, 3, 6, 6. So it's out of 50. What time is it right now? 52, okay. 50. How many did I get wrong? Okay, I lost. Hello. You using this room now?
Here we are from 6 o'clock.
I'm literally about to go now, so.
Is this your secret hideaway place? You love it here, don't you?
Yes.
That's fine. Keep going.
No, I've literally got to go somewhere now, but okay.